Hello there, Vector Podcast Season 2. And today I'm super excited to have a reappearance of Connor Shorten on Vector Podcast. We recorded like a year ago about that time. Some things changed. He is a research scientist at Samai Technologies, the company behind VV8. Here you can see an episode with Bob, and here you can see the episode with Connor as well. And back then, when we were talking, Connor, you've been a lot into basketball. Do you still play basketball?
Yeah, I still play a little bit, and I'll add also to that I think you also have a podcast with Eddie and then Laura, also in the queue of
Yeah,
Weaviate.
we'll add that.
Yeah,
Exactly. And I remember like you've been big on computer vision, data augmentation back then, and your first like guinea pig task was some capturing baskets in the basketball game, and I wonder if you continued working on that at some point.
yeah. I think about it every now and then, but I've been so captivated by the natural language processing and the text search. Honestly, I still think about image search a bit, but yeah, the text search to me it's just so exciting that it feels like there's so much that you can do with it. And yeah, it's been an intense year. I've learned so much, and I think it'll be a totally different podcast with respect to like what I'm talking about.
Yeah, absolutely. I actually love to start also by asking you, what do you feel you've learned in this year that has changed something fundamentally in how you perceive vector search today versus back then a year ago?
Uh, yeah, that's a big question. I think definitely with Weaviate, I've learned a lot about having like kind of the user focus, the product focus. Definitely way more engineering understanding of the distributed data system, replication, cap theorem, all these kind of things. So like the knowledge of the engineering around it, in addition to sort of the machine learning research about like how do vector representations get optimized with deep learning models, and then this whole retrieve and read research. And overall the space has evolved in such an amazing way, and it's just really exciting.
Yeah, absolutely. I've been also following different things, reading papers, implementing Clip, but I still feel like I miss out on so many things, and I really hope we will cover some of them today. Um, and we are on the verge of, I think, maybe witnessing a change in the search paradigm. With ChatGPT. I first I wanted to sort of get your first reaction on this.
Mhm.
Obviously, you tested it. I also tested it actually with when I published my recent blog post on neural search frameworks. And I was like just stuck on creating a title, and I asked ChatGPT, "Can you come up with a title?" And it came up with a reasonably good title, and I actually used it without editing. And I read a bunch of other stories, like for example, how you can avoid fines
Yeah.
for wrong parking and stuff. But then there is this discussion going on, like how it may change search. But before that, what was your impression of ChatGPT?
Yeah, well, I think like everyone else, sort of in this, like reading about say Google's FLAN model, or we've been kind of reading about a lot of these large language models, but we haven't actually really gotten to use them. I think Facebook's OPT model was on Hugging Face, and I played with that. And back at the time, I was mostly like the few shot learning part was like the part that was so exciting, where you could give it like four examples of a task, and then it could just instantly learn the task, and that's like pretty surprising for people who've been doing supervised learning optimization for a long time. And so it was mostly my thinking was the few shot learning, but this chat GPT thing, this reinforced learning from human feedback, this like, I mean, the way that it can talk is just mind blowing. I'm so amazed by it. And I think, yeah, it's really unlocked a lot of thinking about the importance of prompting to me and what prompting means. I used to think that was just kind of like a task description idea, which it still kind of is, but it's like the nuances of it are so much. And yeah, I'd really love to like dive into this topic of large language models and search. And I have a few different dimensions of how I'm kind of thinking about these two things relating to each other. But since I brought up prompting, I kind of want to stay on this one quickly. So Bob and Jerry Liu showed me this thing called GPT Index, and GPT Index has this strategy for prompting GPT for summarization. It has other things, but this is one thing that just really stood out to me. And there are like two strategies you can use to summarize long text with the large language model, you can either create and refine, where you go paragraph by paragraph and you say like, you start out by, please write a summary of this long text. You'll receive it paragraph by paragraph, and then it iteratively updates a summary. Or you can have this tree where you chunk it up like, as a tree, and then you couple it like recursively and then build up the summary that way. So this kind of thing about like how we use these large language models, all of it is so interesting. And so I guess kind of, let me pass it back to you. And I'm curious, like, how do you think large language models will change search?
Yeah, I mean, I'm still kind of learning it, and I having built search engine before vector search, using like TF-IDF basically. I knew the cost of doing it wrong, or sort of focusing too much on precision and then paying a huge bill because of that. So, like our search engine, for example, back in the days when we indexed on sentence level and alpha sense, would eat something like half a terabyte memory. And, memory was never cheap. Like it was very expensive even back then. And so we had to figure out ways to retain precision, not lose recall, or maybe even increase recall, because there was a problem with this precision oriented search, and stay within the budget, right? So when I think about language models myself, and I also worked at Silo AI at one large client, applying these models at web scale. The problem at web scale is that you really need to go sub-second, and not just sub-second, you need to go like 10 milliseconds or so, because all of these add up, because you have so many components in the search engine. It's also multilingual. It's also serving a specific country, with that specific latency requirements and stuff. And then there is indexing, how quickly you can index things, right? Because you may also face bottlenecks there. So these are the things that I keep thinking about, but also the thing that we talked a year ago in the same podcast, Vector podcast, is that the models like trained by Microsoft, for instance, I can hardly imagine deploying them
Mm-hmm.
today in my practical setting, because they will have like billions of parameters, and so they will be probably slower. And also, how do I fine tune them? How much server capacity I will need to fine tune them? And so that's why I thought, from the discussion with Multi Peach, right?
Mm-hmm.
He pointed me to the Atlas paper, where they basically are able to, with a few examples, fine tune the model so quickly, and it will have substantially less parameters. So it becomes more practical, both on fine tuning side and also on serving side. And these are the topics that I keep thinking before I enter the, is it ChatGPT? Is it sexy? Is it cool? Is it answering my questions? Can I actually deploy it and not have angry faces from DevOps saying, hey, you just crossed all the, like, we are low margin on search and you are just, way above that. So sorry, we cannot deploy this. So these are the questions I'm thinking about a lot.
Yeah, that I think there's a couple of things to unpack, and no one's helped me develop the abstraction around the end-to-end search framework more than you. So thank you. So with the pyramid diagrams and these kind of things, it's so helpful. And yeah, you mentioned like the approximate nearest neighbor. Then one up, you have where I see is the information retrieval layer, where you have the dense vector search, BM25, SPLADE, Colbert, that layer, and then at the top you have like what I think is going to be the ChatGPT layer. That's like, that would be my current prediction. And we're going to talk about neural search frameworks. I think
Yeah.
more on the Weaviate podcast. We'll really dive into that. But yeah, the yeah. Well, maybe to stay a little bit. One of our favorite partners that we've been working with is Neural Magic, and Neural Magic is doing sparsity inference acceleration, where they've recently, one of their papers is about getting the 175 billion parameter GPT model to run on a single GPU. I know that you can probably compile these large language models on like NVIDIA Triton server and do it that way. But I think that this sparsity acceleration for CPUs is just incredibly exciting for that particular dimension of it. And yeah, I think what you said inspired so many ideas that I'm.
Yeah, I sort of like what I value in your approach is that you run probably like a basketball player converted into a marathon runner with the same capacity you have to play a game.
Mm.
That you basically run super quick and fast and long distances, on the research side. And I love this approach really, really, because it opens up a lot of opportunities. I sort of like, because I come from the engineering background. Yeah, I did my PhD, but it was like 11 years ago. So I most of my time I spent in production, grade systems. And every time you just try to move a little bit, like, okay, let's add this, and oh, the cost is this. Oh, sorry. Okay, it will take me now to 2 more weeks to index my content. So
Mm.
can we afford this? What is the use case? So you trickle back to like almost like product level management. And so you will get these questions inevitably, like, okay, why are we doing this? Like, what's the actual trade-off? What's the benefit of bringing this into production, right? And but at the same time, I'm fascinated by this. I mean, this will not stop for sure, right? Would you agree to that statement?
Yeah, I think, and there's, so I know Hugging Face has recently published they open source a data set they did with Surge AI on getting these human annotations to train the reward model in the reinforced learning human feedback strategy. So I think there'll be an open sourcing of the data that you need to train the models, and then yeah, I think pretty soon there'll be open source versions of it. I think OpenAI. I'm very curious about this like kind of data flywheel idea, where by open sourcing the model, they spend a ton of money on letting you use it for free, but then they get the data of how you want to use it. And so I'm very curious how that leads to a better model. My PhD advisor is a world-class expert in class imbalance, like understanding that machine learning models, they do not perform well on long tail. If you have an imbalanced data set, it's a lot of like the bias discussion, things like that. So I'm curious, maybe it helps with the long tail getting all this data. But yeah, it's still not exactly how it will get better. I think one thing I've said previously is like there was this paper from Emily Bender and Caller is the last name. I'm sorry, but anyway, it's called "On Meaning and Understanding in Big Data," and it makes this argument that it's like language models, by predicting the next token, will never achieve meaning because it's like an octopus underneath the ocean of two stranded islanders, and it's just mimicking their language. But if something like a bear is to show up on the island and it goes, "Help, a bear," then the octopus is like, "Oh, I don't know what a bear is, so I can't help you anymore."
Yeah.
But I think what we're seeing with the reinforcement learning thing is that it's like it's acting. There's this other paper called Experience Grounds Language. That's about you need to act. It's like the levels of sort of developing meaning, and one of it is like about the importance of acting in your environment. I'm kind of going on a rant here, but I also see like this causal inference stuff, and Judea Pearl has this ladder of causality where it's you act, you make interventions, but then the at the top of the ladder of causality is you can understand counterfactuals, and so that last part, I have no idea how that's going to be achieved yet. But clearly, ChatGPT is now like acting, so it's different from the
Yeah.
predict the next word thing.
Yeah, I think coming back to ChatGPT, like what impressed me maybe the most is, so I had this problem. I was working on billion scale in a search algorithm with a group of researchers and engineers like almost a year ago. So I invented this algorithm. I called it Candy, like of course not meaning my surname, but in any case with a K. It's all open source on GitHub. I'll make sure to link it. And so the problem was that it would work on 10 million vectors, it would work on 100 million vectors, but it would choke on 1 billion. It would
Hmm.
basically run out of memory. And I did it entirely in Python, right? So maybe I should have chosen in retrospect some other language. But in any case, I wanted to make this work. I couldn't. I ran out of time and I ran out of compute resource because it was given to us by Microsoft for a limited period of time. So what I did is that I pasted that code into ChatGPT and I said, yeah, first of
Mm.
all, I tried to paste the whole thing, but it said, well, it's too long. So I had to focus on a specific part where I think the problem, kind of lurks. And it gave me the answer. It said, okay, maybe try avoid using numpy arrays as much as you do. Try to pre-allocate them. Try to reset them. And actually, I did that. I just didn't paste that portion of the code which was doing this. So the system didn't know that, but it was on the right track. But then when I did it a day later, the answer changed. The question was exactly the same, but the answer changed, and that kind of made me really like, what's going on? Like, is it learning as it goes? Can you explain this part? Like, have you seen this in its
Oh,
behavior?
like with stochastic generation of the
Yeah.
chat GPT. Sorry, I was like, I was trying to follow along with the, I think we were going to talk about like approximation error with the ANN search as we scale it. And I didn't know we are coming back to the chat GPT, but, yeah, so it's like a tree decoding where, it has a probability density on the length of the vocabulary, and you can take several paths through that tree for what you're going to output, and you'll often randomly sample through the tree. Does that make sense? Like,
Yeah, it does.
yeah.
But I mean, the answer was kind of like, in some sense, these two answers were complementary to each other, right? And maybe I
Mm.
could go on and say, hey, what do you mean by resetting? Can you, because it didn't provide any code examples. It would just say
Oh,
reset, and I
oh.
was like, what do you mean by reset? I don't have such a method. Like, so I think that was maybe impressive part of ChatGPT, and
Hmm.
just to close off on that, there was a recent discussion on relevancy and matching text Slack, where a lot of the search people sit. There was this argument against ChatGPT that, let's say, if you go use DuckDuckGo today, you will see
Mm.
the links, right? You can go and examine the links, and you can actually verify the information to some extent, maybe not to full extent, but to some extent. In ChatGPT, you can do that. There is an answer, that's it. So it's quite a jump from being able to kind of seemingly check the is it trustworthy to, well, you have no way to do that. What do you think of this aspect?
Yeah, that's brilliant. It makes me think about, like, well, very broadly, it makes me think about artificial general intelligence compared to super intelligence, so to say. And like, I think about the artificial general intelligence, like, because OpenAI, they've published Web GPT and Instruct GPT. So Instruct GPT is like the reinforcement learning from human feedback part, and then Web GPT is like the whole idea that we're super excited about at Weaviate, where you search for context to append to the input, and then like if you say like please ground your answer in this information, and then it's a paragraph about like how the BM25 algorithm works. Like I use this personally to help me get to hybrid search and understanding it. And so like if you give it the context, it's so much better. And so I suspect that ChatGPT under the hood does something like a Google or a Bing API search, and so it's like general, but yeah, this idea, like, so then this idea of super intelligence, and because I've been like, can I use ChatGPT to help me write like, blog post, survey papers, things like that are relevant for trying to be a master of search. And what I need from it is more so like citation recommendation, right? Like I need it to go into like Leo Boystav's
Yeah.
publications and parse it out for me and help me understand what he's done. So it's like the specific information, and then yeah, the real. I mean, U.com also has a really brilliant thing where it's search engine on this panel and then the chat GPT on this side. So it's
Yeah.
like a user interface problem, I think.
Yeah. But I mean, maybe even, yeah, I totally agree with you that user interface definitely creates the bias. How we like how you use traffic lights today. They go like red, yellow, and green. They don't go upside down, right? And like if you see an upside down, you will think, well, this is the wrong traffic light. I'd rather not cross here.
Yeah.
But like, so kind of like similar here, like with the search engines, we are used to seeing urls and being able to click there. But of
Mhm.
course, if you take Google, or I guess Bing does that too, they also pre-generate these answer boxes, right? So you can click there, but I don't think you have a url to verify the source of this information, if I'm not wrong. you know
Yeah.
so they're already playing with incorporating this knowledge from a language model, right? And they
Mm.
they they look at you, and of course they also want you to spend more time on their page, which is probably not good, but we'll not discuss that. So they don't share the traffic further, but the thing is, they still play with the idea, okay, what if we try to answer not just with the url and summary, but actually with the actual thing, right? With the actual answer.
Oh, so that comes into like the extractive versus abstractive, and like whether you want the question answering models that classify the answers in the context.
Yeah.
And yeah, I
Yeah.
think that still has a place for sure. I mean, it's super lightweight. As I mentioned, Neural Magic, they just did a sparse question answering model that can run on CPUs super fast. And yeah, I think that approach is also just going to be more cost effective for a while.
Yeah, exactly. But you mentioned BM25, and I'm curious. Like I've been trying to approach this hybrid search topic, but I think you went ahead already. So, and I was just wondering, like, what's your take on this topic? Like, can you little like intro it to our listeners? But also, why do you think it's a good idea to build like a hybrid search? You know, combining keyword retrieval with a dense retrieval.
Yeah, awesome. I'd start by saying this has just been like the most satisfying project I've worked on since I've joined Weaviate, and just being a part of this team. And it's been, like a big team working on hybrid search, and it's just been an incredible experience. So I guess starting, yeah, the motivation is BM25 has this, it builds on term frequency, inverse document frequency by adding like this binary independence model in the IDF calculation. And then you also normalize it for the length of the document. There's just like these subtle differences that make it different than TF-IDF, but you could also use TF-IDF in hybrid search if that's what you were after. And so then you also have the vector search, and then you have this rank fusion. So we found this paper where they have 7 different strategies for rank fusion. It's like RRF, Borda, I don't know, come some, but in the end we just went with RRF, reciprocal rank fusion, which is just Eric has recently published a blog post that shows the equation and just tells some of our thinking around it. But it's where you just combine the ranks compared to say combining the scores, because BM25 has a score particularly, and vector search has like a distance that returns. So you might look at some way of like linearly or non-linearly combining those scores. And I've done some experiments with kind of my thinking around it was like, okay, what would be like an optimal alpha per query? Would that be, maybe like a conditional model? Like, so I tried this with the few shot learning of GPT-3, where you run a few examples of the optimal alpha, and then you try to see, how would you like to weight BM25 in dense vector search given this query, and see if that is productive. But I found, and this is a very interesting thing, because I think people have this idea that BM25 is like very interpretable, but in my experience it hasn't been that. I when you're doing longish queries in long documents, and maybe we can talk about long queries versus short queries, but I find that trying to decode why BM25 was better than dense search for some particular query, I find that to be impossible. And maybe someone will prove me wrong, and I'll look forward to seeing that, honestly. But like, there's this example that we have, as Erica was developing the Weaviate Air demonstration of hybrid search, where the query is how to catch an Alaskan pollock. And the idea being that the dense vector search contributes the disambiguation of catch that it refers to fishing, and that BM25 is specific to Alaskan pollock. But I haven't been able to just like inspect that kind of behavior as I look through the beer benchmarks. It's just I'm super excited to talk about that and how we've been evaluating it. But yeah, let me pass it back to you and ask about your experience with BM25, or like the keyword and the dense search particularly, because then I'd like to kind of take the topic to just arbitrary combinations of retrieval methods, not just BM25 and say DPR
Yeah.
or whatever.
Yeah, I think I remember even before the dance search appeared on the scene, we were experimenting with sort of like making TF-IDF, which is BM25 is like an add-on. Like BM25, I think stands for best match. So period. So solved. Uh, problem solved. But like one of the questions that, the reason I love working with product managers, and at the moment I am a product manager, so I took the other side of this thing. Maybe we can talk more about it in the VV8 podcast. But the reason I love talking to product managers is because they don't know anything. Maybe they don't know that much about algorithms as you, and they don't code maybe as much as you, but they do care. They are the stakeholders of the end result, right? So when they go out, talk to sales or to the end users, they will not get a question which alpha you have used. Now coming back to your example, right? They will say,
Mhm.
hey, I typed cat 3 times in my query, and I still see that the document that mentions it once is at the top. How can you explain this? Uh,
Mhm.
I will try to link. There is a consulting company. I think they're based in Boston, actually. By the way, I just forget their name, KMV or something. So they have a really great presentation on Haystack Live, I believe. Where they go super deep, and I recommend you watch it, super deep on how TF-IDF screws up our understanding of how things should work when they don't,
Mhm.
and they go by, how many times the word cat is mentioned in the document versus how many times it's mentioned in the query, and you can do all these combinatorial combinations, and then they kind of like explain what you would do to kind of solve it, right?
Mm,
And you basically develop this intuition. Another thing is that I found useful, and it's also mentioned in the relevant search book by Doug Turnbull and
mm,
Jerry Berman, that you can use, like, if you would use like let's say Elasticsearch or similar system or Solr, you could actually build a function which explains the query step by step, right? So it
mm,
basically prints you the tree of how it actually came up with that final answer, with that final score, and how that specific field, like for example at TomTom, I cannot go into much specifics what we do at TomTom, but basically it's geographic search, right? So you type some destination, let's say an address or maybe a POI name, point of interest, like a shop, and it's multilingual as well, right? So obviously your query may hit by accident sometimes in a wrong language
mm,
field, and so the only way to know this is to print that query execution formula, if you will, right? And so you will see, okay, it hit in that, let's say, I don't know, a French, but I wasn't intending French. I was doing German or something. Why did it do that? And you start reasoning about how did I create the tokens? Because when you tokenize your text, it's the same problem as in dense search in a way. Like when you split text
mhm,
into paragraphs or sentences, there you need to split the tokens. How you do split the tokens is dependent on how you model the semantics of what you are converting to a token. So you should not convert string to a token, you should convert meaning to a token. So if you capture meaning in that token, then you are done in a way. But then coming back to your question, I cannot answer it fully now, but I highly recommend that talk by Kenvi. So like you need to see how term frequencies and inverse document frequencies play together. And also, like in BM25 versus TF-IDF, you have the term saturation issue, which is kind of mitigated in BM25 to some extent, right? So meaning that if you have two documents, um, if you have two terms which occur, like one is like million times and the other one 1 million plus one, TF-IDF will be unable to distinguish between these two. But like BM25 is still sensitive to these things, and that's why it's a little better, right? So I think it solves this term saturation issue. I don't know if I answered your question, but
No, no, yeah, I think so. Yeah, a couple of things. I really want to continue on this TF-IDF versus BM25, and then add versus SPLADE to it. I think this like pseudo relevance feedback, is that like the phrase they give to show that like if you're searching with BM25, you say if you had added this key, like you have the gold document, and you're like, how would I have modified the query to produce that document? Is that it? So I
that's
think
one
with
way.
yeah,
Yeah,
so
that's one way. Another way is to how would you modify the indexing? That's more in your control, right? So how you would modify the
mhm.
indexing, for example, you would in some cases you can remove duplicates or something, right? So like you don't need them or
Mm,
something like that. You can split the term by numbers or something, right? If they happen to occur inside the term, something like that. I'm making these
right.
examples up, but I'm saying that you have more control in the indexing than in the query. But in the query you can model like query similarity, for example, right? So yeah.
Oh, that's super interesting. Yeah, the way that you do like the text pre-processing, like stemming, stop word removal, all that bag of all that. That's what I hope dense vector search can kill all that. I hope you can just type anything can go into it. But
Yeah.
and but yeah, and so I think there's this thing called like decoding the latent space of a vector search model, on that other idea of what query would have produced this, where you would take the you would train a language model on document query pairs, and then it would generate a query that would have matched the document. Maybe that's useful, but I'm very curious what you think about this idea of SPLADE vectors. So SPLADE vectors is like you keep the mass language modeling head, and so you encode the thing into the vectors. So the mass language modeling head always only takes in a vector as input. You always would mask out wherever the mass token was, and then send just that vector to the mass language modeling head that will produce like a sparse distribution over what would replace it. And so I think the idea behind SPLADE is that you do that for each token, and then you just kind of average all the vocabulary distributions, and that gives you a sparse vector that represents like the like happy, euphoric, ecstatic, like the kind of synonyms behind it. Do you like that kind of idea?
Yeah, yeah. I like that. The fact that I think we can step back from like this dense vector limitations and go back and try to capture what sparse vectors do. Because if I don't know if you watched the episode with Doug Turnbull, but he actually shed the light on this really well by saying, hey, if you take the keyword retrieval inverted index, you deal with like probably hundreds of thousands of dimensions, unless millions, unless billions. Like in some of the indexes, we had at least million per term, right? So that's like million positions, most of which are zeros, because this term doesn't occur, in specific doc, but like doc ID, but like it occurs like in a few. And so in dense retrieval, you sort of like compress all of this to, let's say, 256 dimensions, and inherently you lose the precision, right? So it becomes more like recall oriented rather than, in sparse, you basically like what also amazes me in sparse is that this is probably like a little bit like going back to NN algorithms, right? So like an inverted index, it's basically like a hash table. So I have this term, it's like order one lookup in the hash table, and then you leapfrog, you use this leapfrog algorithm implemented really well in Lucene, for example, how you jump over long strides of consecutive doc IDs because you don't really need to examine them in an AND query. Let's say if it's cat and dog, you know that cat occurs in the document ID 5, well, I don't know, like 10, let's say, and for dog you are on 3, so you can
Mhm.
leapfrog all the way to 10. You don't really need to check all this because they will never occur together. So for or query, that's another story because that's a union, but for and query, it's an intersection, so you always need an intersection, and you can then stop early because you don't need 100,000 results on the screen,
Mhm.
right? And I'm still actually curious on how would you know when to stop, because what if you didn't find the document that is even more relevant than what you have seen so far? But that's like a matter of debate, I guess. But then you start scoring them and then sorting them by relevance, right?
Yeah, sorry if I'm a little behind them. So is this referring to how you can use like an inverted index to calculate the BM25 scores? So I would, with my document collection, if dog appears, dog and
Yeah.
then the documents so that when I'm calculating.
Yeah. But like the I guess the comparison I wanted to make to dense search is that, like, or vector search, is that there on the base data structure. First of all, you have a choice of the
Mhm.
algorithm you want to use. But let's say we take HNSW, which is the most
Mhm.
popular, right? Also implemented in VV8, I know. But like, you don't know when you enter the first layer, you don't know
Mhm.
where exactly you will end up. Like, so like with hash table, I know exactly where I'm entering, and I know that I'm exactly in the right place, right? And you can also expand your query with synonyms. Then you enter more points in the hash table, and you start traversing all of them in parallel, and you come up with the answer. But in dense search, you need to like accept the uncertainty of navigating that graph. You don't know where it will land. It has certain limitations and trade-offs, and then it will pull up, some nearest neighbors, and probably you should be happy with them because, or otherwise you need to do it twice or thrice and so on. You see what I mean, right? So like
Yeah.
they're fundamentally different also on search side.
Oh, in like the stochastic nature of the.
Yes.
Yeah, and
Exactly.
I read this paper called OOD-DiskANN that talks about how much the distribution shift can impact the graph-based Vimana structure. So Vimana is like HNSW, but you flattened it, so there's no longer the hierarchy of layers. It's like all in the same thing, and then you can put it on disk, and it's like a little
Yeah.
cheaper to run, I think. uh, yeah, it's fascinating. The whole indexing, the part that's like kind of the meat of this. That's where I
Yeah.
see, at least, especially from Weaviate's perspective, that's where I see. And in addition to the UX and making it like a very developer friendly tool, well, there's a few sides to it because there's also the distributed database part, and all the written in Golang, the concurrency control, the replication, the backups, like all these kind of things. That so there's definitely like some things to it, but that approximate nearest neighbor search, and I know that you have this experience with I've listened to a ton of your talks, and you introduced me to the ANN benchmarks when we first
I'm
met.
glad.
So yeah.
Yeah.
But yeah, I see it there as being like three levels of errors that propagate up. There's the errors from HNSW and say product quantization. Then there's the errors from the vector representations to begin with, and then there's maybe the errors in like the question answering model. So if you wanted to have like natural questions open domain QA, you're looking at like three layers of cascading errors that are sort of unrelated to each other.
Yeah, exactly. You put it really brilliantly that you like, and I think if I may summarize it, I anyway to kind of wear this hat of the person who is creating this vector search pyramid and stuff. I'm not the
Yeah.
only guy doing this, but I keep doing this because it helps me
Mm-hmm.
to stay comfortable in the topic and sort of, okay, I'm looking at it from this angle, and if you accept it, stay with me. If you don't, you may as well augment it or something like you did earlier with some levels in it. Uh, but like it's just you need to accept that uncertainty, like you explained, and also that uncertainty that like in DiskANN paper, they explicitly show that in HNSW you may have unreachable nodes. And they
Mm-hmm.
counted something like 1,000 nodes were completely unreachable from any point in the graph. Like no matter how you search, how long you search, what are the values for your EEF and M parameters during index construction and search, you just don't reach them. And that's, I think that's somewhat similar to the inverted index search, where you have like 1 million doc IDs per term. How do you know when to stop? It's also like you may never reach
Mm-hmm.
the documents that you should have visited, but you just deliberately decided to stop prematurely because you don't have time. You have to return the documents within, I don't know, 10 milliseconds, so you have to make trade-offs. But they are ordered naturally in the increasing order of doc IDs, right? They're not ordered by, does this question answer anything? Does this document know anything about cats, or it just mentions them in passing? Does this
Mm-hmm.
document knows anything about Twitter? Does it describe Twitter, or it just says, please contact me on Twitter. Here is my Twitter handle, right? Like complete noise.
Yeah.
So you see what I mean, right? So like
Yeah.
there
Yeah.
are, I think, in both approaches, like on fundamental level, on data structure level, we deal with these fundamental limitations. It's like gravity law. Like you cannot jump off and fly to moon or to Mars, right? Without
Mm-hmm.
additional like thrust and devices and stuff.
Yeah.
So do you feel the same? Like, does it resonate?
Oh yeah. Well, firstly, thank you. That you've just explained that concept to me for the first time. I'm just now live on the podcast understanding that concept. So, but yeah, it's very cool. Like the sorting the inverted index to prioritize documents, maybe by clicks. Like clicks would be like the most sensible thing if it's like web pages, so to say, and you sort the documents and then you have some kind of, you could probably calculate how much time you have to search and how much that lets you go into the invert index. Yeah, that's super interesting. I think it's very interesting for Weaviate with the hybrid search in the BM25 index, because I know the inverted index has been explored because we have this like neurosymbolic search where you would annotate properties. Like you're searching through, let's say you have a billion sneaker images, but you've also labeled the color they are. So you have red is the color, and then you can use that to filter the search. So there's definitely been some foundation in pre-filtering and integrating these kind of symbolic inverted indexes with HNSW. So it's not like the first time Weaviate's ever exploring that, but there's definitely nuances with the BM25 because of the cardinality of how many terms you have. Like with the document, I think you're splitting it, I don't know, 300 words, yeah, right? Like 300 words per property. So just the size of it.
Mhm.
And I mean, starting to go into the thinking around like the sizes of things, it inspired me when you're mentioning the compression bottleneck from sparse to dense. I was thinking like, okay, let's say we have 384 dimensional vectors that have 32 bits per vector position. Like, what is that? Is that 384 or 32, 384 to the 32, or like that? That's still a massive combinatorial space, right?
Yes.
Yeah.
Yes. Exactly. And you said, like, is it even the model that captures everything we need to capture, right? All
Mm.
of these are numbers. Of course, it's kind of number representation of the model's understanding, well, understanding in quotes, of the objects that we index. Uh, but I guess, like, for me, like, and you're way ahead in this. I feel like that with VB8 development, like, of me, what matters to me when I was like a search engineer day to day is what tools, not necessarily tools as in specific programs, but like tools as in algorithms, approaches I have to control the process, right? So if somebody
Mm.
comes up and says, hey, can you look in this query? Can you debug it? First of all, like, explain queries, one brilliant way of doing it, and that's where you start. But then once you understood, aha, there is a problem that it hits this field, or I give too much of a boost in this situation. What should I do? So you start like tweaking these parameters, and you have these tools in your hands, right? You can do that. In vector search, I don't know. Like, I have like probably fine tuning as one tool, right? So like if
Mm.
Clip stops working on these images, I can go and
Mm.
fine tune or bird. Um, but what else do I have? Like, I can also tune some parameters in HNSW or DiskANN or something. I can make all these 1,000 nodes reachable like they did in DiskANN. I can choose disk over RAM if I want to save on on cost and stuff. But what
Mm.
else do I have as a control to actually go and debug and fix that specific query? Like, what has been your experience on that, or maybe thinking?
Yeah, I think you've named them all. I mean, I know I've seen like the tuning of the EF construction, as you mentioned, with HSW, and I guess something that I'm really excited about with these beer benchmarks, and maybe I can introduce it now because I think it helps with this idea of model selection in terms of the user's perspective on how can I debug my system, how do I fix my search system. So the beer benchmarks it's about diverse text retrieval. So it's like Arguana, NF Corpus, Trek COVID. There's the difference is instead of saying that the search image net is going to be MS Marco, which is like 10 million Bing passages and like a million labeled queries. So it's like the image net idea of like this general source of info. Like ImageNet is like a massive collection of images labeled in a bunch of categories. So it's like is MS Marco the search ImageNet, but it seems like instead we're going for diversity with beer. And I think also if we want to talk about intents and instructions further, I think actually beer is I think beer had another. There's latte, like LOTTE, capital T's and lowercase. But
They go beverages, right? So
yeah,
beer and latte. That's
yeah.
cool.
So there's like
That's
an
cool.
equivalent to beer, and then there's also miracle, which is for multilingual. So there's a lot of these like diverse text retrieval, and then it's expanding where you would label it with the instructions as well. And I don't remember the names of these data sets off the top of my head because it's very new, but I know this paper called task aware retrieval with instructions, and I think there's a model, another paper with a model called instructor. So this is the idea where you also label it with the intent. But anyways, let me go back to the focus on like how does a user debug the search system and say how can I fix it. So the idea with the beer benchmarks, like one idea would be that we could test several different models, and you could maybe say like, okay, well, I'm building a nutrition search app. So I'm like bodybuilding.com or something like that. And so you would look at the NF corpus results, and you would see the performance of the different models, and that would maybe help you take a different model off the shelf. But then what you're saying with like fine tuning it, I suspect that fine tuning is going to be a super powerful lever. I think if you fine tune, like, and maybe later, there's so many topics I want to talk to you about, but like with
Yeah.
the idea of, I've been building a Weaviate demo of the podcast search. So I've been taking the Weaviate podcasts, parsing the transcriptions and putting them in there. And my temptation to like fine tune it and start thinking about this positive negative construction for that. I mean, I think in general with Weaviate, we're kind of, letting like, we use OpenAI models, Cohere models, Hugging Face models, and it's like, we're not really training the models, but it's just such an interesting thing to tune. I know Gina AI's fine tuner is extremely interesting. That I do find myself like constantly pulled in that direction of like wanting to train models.
Yeah, absolutely. I mean, when we presented Moves at Berlin Buzzwords last year, we actually said we also have Mover, which is the component to allowing
Mm.
you to fine tune a model. We kind of like don't have it for prime time, but I've been like really fascinated, kind of coding a bit of that and checking how well it can work in a more generic way, because I think fine tuner allows you to plug in several models, and
Hmm.
like, because different models have different inputs, they have
Yeah.
different like setting to train and fine tune, and so you need to be aware of that. Like clip is a kind of two tower in a way, right? So you
Hmm.
do need text, you do need the image, um, but I think I feel like, coming back to the question, like what tools I have, I feel like fine tuning, and I feel like you agree to that fine tuning is one way that should be more available to the masses, should be more available to
Hmm.
the users in a way that they are aware of this tool and they know, best, sort of like know how to use them, and also pitfalls you may fall into. And I think
Yeah.
this is what you brilliantly described like a year ago in the context of computer vision, like data augmentation, right? So like,
Hmm.
it's one thing that um, you can feed some manual examples, but how far you can go. And like in your basketball example, like you've been manually labeling some examples, like you run out of patience in a way, right? Okay, you can hire people to do that, but is that scalable? Probably not. And
Hmm.
also new trends come up, like if you take a business specifically working on e-commerce, or I don't know, full text document search, things come up every week maybe, right? So like,
Hmm.
I don't know, Tesla releasing Cybertruck, and you don't have it in the model. So it actually, like in
Hmm.
your example, what was it with the ocean and like
Oh
if
yeah. Yeah, I
so
hear exactly like how to catch an Alaskan pollock, and then let's pretend that
yeah.
Alaskan pollock is a new fish that suddenly
Yeah,
existed.
exactly.
Yeah.
Like, or like you maybe with vector search, you may try to find what could be the most similar object, but it may also be wrong, right? Or
Yeah.
in the case when the distance is so big that it doesn't make sense anymore to consider this as a candidate, right?
Yeah.
So this is very interesting. Like, and I hear that you really want to like dive into fine tuning topic as well, right?
Yeah, well, that idea is amazing because there this argument, and I also when I interviewed Malte Peach, he gave me these three reasons to favor the retrieve then read approach to large language models, and one of which was this idea that you can swap out the information to update it with new information. Cybertruck becomes a new thing, and then you can put it in the context, and now the language model just has to retrieve reason across the context. But then, as you say, the embedding model doesn't know about the new thing, so the embedding model, also isn't going to pick it up. And so, yeah, I think that continuous updating. One idea that I'm just incredibly excited about. I haven't figured out how to make this work yet, but the idea would be the MLOps problem of this is you need to re-vectorize your data set, which
Yeah,
if you have
expensive.
like yeah, so the solution maybe is that you could vectorize like 1,000 representative documents, and my hypothesis is that the proximity graph from, I want to say Vimana more so than HNSW because I I barely understand graph neural networks, let alone trying to make it a hierarchical graph neural network. But like if it's the proximity graph, maybe you can. It's like a psychogan. It's very similar to like image to image translation or any kind of it's a vector space to vector space translation. And so you input the vector, output the change in vector. And so can you vectorize like 1,000 and then propagate that throughout the graph or throughout the corpus? And maybe that proximity graph has some kind of bias that facilitates the optimization task, or maybe the graph neural network thing is too much overhead, and you're better off just having like a transformer that takes in a vector, outputs a vector. But yeah,
Yeah.
this idea of like how do you continually update your embedding models is fascinating. Yeah.
Yeah, especially the MLOps aspect of it, as you mentioned. Like, if we were to insert new neighbors into the existing graph, right? Would that change it to
Hmm.
favor something more recent, or would it like break something that we didn't want to break and things like? But in some sense, if you think about coming back, like we are still in the realm of this hybrid search topic in a way, right? If you look at BM25, OTF IDF approach, right? So if you compute, so you term frequency is only dependent on this document, right? So that's fine. It's kind of independent of all other documents. But
Mm-hmm.
your inverse document frequency is dependent on the whole corpus, which is indexed in that shard, by the way. That's another like big topic, which is kind of like crossing the boundary of, is this just infrastructure issue in slash engineering, or is this kind of like research issue?
Mm-hmm.
And it's like it's fuzzy. It's a blend. And so for that shard, you're gonna have that local IDF, unless you build a higher level cache, which
Mm-hmm.
will keep track of each individual shard's IDF and roll it up to the global IDF. And like if you look at Apache Solar, I believe they had a contrib module or something implementing this, where you can actually implement a global cache with IDF, which will live on top of the shard. And now you're coming back to MLOps, you need to make sure it never dies, because if it dies, you go back to like shard level IDF. And
Mm-hmm.
so that becomes dependent on, okay, I have managed to stuff a lot of documents about cats in this shard,
Mm-hmm.
so the IDF is like this, and then I stuff a lot of documents on docs here, so they become like unbalanced, if you know what I mean. So
Mm-hmm.
it's not a healthy mix of term statistics in your collection, right? And that will influence a lot of things. Like you may say in some cases it's okay, but in some other cases it may not work if your query contains, both concepts and they're unequally represented somehow in your collection, right? So I mean, does it make sense? I mean, so it's
Yeah,
like
yeah.
you do have limitations also, and not limitations, but maybe I should pose it in more positive way, research tasks, right? So research challenges, like
Mm-hmm.
what should we do? And I hope that in some sense dense search is pushing us to think more and more about this, and maybe some things will backlash from vector search back to the classical keyword retrieval, and maybe some new data structures will even emerge to tackle these things.
Yeah, I think that idea that you're describing on the IDF caching is super interesting. I think it it is inspiring me just thinking generally about how we're trading knowledge on this thing in general, and having this podcast and having this content and this communication, and how we've done like our first iteration of BM25, and yeah, like learning so much about the index structure. It's really really interesting. I was thinking about like, oh well, how about the SPLADE vectors? Could we just kind of update the mass language modeling head to get the new terms, and would that be easier than this kind of global cache
Hmm.
idea?
Hmm.
And is it more forward thinking? And then yeah, it's really interesting. I think maybe one other idea is this thing called Colbert, which is like a token level representation thing, where it's like they call it late interaction, where first you do the standard vector search, but then you keep the token vectors for each of the vectors, and then you do that, and then they've had efficiency improvements on that. So like I think they in the original Colbert they've recently published this paper. I know Christopher Potts and Omar Khattab. I'm sorry, I don't know. Like I'm trying my
Yeah,
best to
we'll
like
find
know
it.
give everyone credit all the time, but anyway,
Yeah.
but in this paper they described it like the original Colbert is like an 154 gigabyte index compared to like 1 gigabyte with other methods, and it's so yeah, like efficient indexing. I'm definitely ranting a bit,
Yeah.
but there's like a big thing to unpack. There's so much depth to this, and that's what makes working in this field so exciting, is that there's so much opportunity, so much to explore.
Yeah.
Yeah,
Yeah. And so much unsolved as well. I
yeah.
don't know if you wanted to continue a thought.
Oh
Uh,
no, sorry. Yeah, it was just.
but yeah, I mean, we are branching out, but like actually one thing that you just reminded me, there was a maybe I should start writing a book or something, because like the moment I remember this, I should write a chapter and then keep adding and then publish it. Maybe you can be my co-author or something.
Yeah,
um
awesome.
but I was just thinking, it was it like 10 years ago on Berlin Buzzwords, there was a presentation by one of the engineers at Twitter. I don't know if he's still at Twitter, and I forgot his name. I remember he was German, um, working out from San Francisco, and
Mhm.
he basically coming back to that issue with sorted document IDs, right?
Mm.
What they did at Twitter, first of all, the scale of Twitter is such that you cannot possibly store Lucene index on disk and then go and retrieve it because, well, it's just way too slow, right? Um, what they did is that they moved the whole index into memory, right? So they had to rewrite Lucene to kind of like this memory friendly data structure. And one thing they did in particular is that as tweets come in, each tweet is a document. It gets its unique document ID. And they would append this new document ID to the postings list in the end, right? So for this term, so they would decompose it into terms bag, and then they would know, okay, I need now to update that specific terms posting list. So the posting list is just the array of doc IDs. So they would put that tweet's doc ID in the end, and as the new searcher comes in searching tweets, they would read backwards from the end. They wouldn't read from the beginning of. So basically what they did is that they kind of like encoded the temporal nature of tweets and and users wanting to search and view the tweets which are the most fresh. So like I don't know if like you're the heavy user of Twitter. I do use Twitter
Yeah.
occasionally as well, but like on
Yeah.
Twitter, like when I log in and I check my timeline, like usually I see something super fresh and
Mhm.
then I keep scrolling, but like uh, not like anti-props to Twitter, but it's a nightmare to search on Twitter. Like when when I search
Mhm.
something I know existed like a week ago, there is no way for me to find it
Mhm.
unless I know the exact tweet ID, right? And so at some point I was even indexing tweets, actually direct messages I had with few people, um, in Solar, and then basically searching them. So because it was way faster than searching them on Twitter, because like if you have 5,000 direct messages,
Mhm.
scrolling through them will take half a day. So because they keep
Mhm.
loading and loading. So basically what I'm trying to say is that they optimize the data structure for the nature of usage of Twitter in such a way that they bias to the recent tweets, and they
Mhm.
don't care if you will have to spend a day retrieving like super old tweet. Like it's like so minutia use case for them. For the
Yeah.
majority of users, 99% of users will only want to see and consume the latest thing. So in some sense, this is kind of the effect of optimizing to the usage. Like
Mhm.
what you say, we could optimize, like SPLADE or similar, sparse LLM or something
Mhm.
to kind of like learn, that latest beat, and maybe there is a high chance of it being retrieved as well. So we
Mhm.
might as well bias the system to that. But then, of course, there is catastrophic forgetting thing and stuff like
Mhm.
that.
Oh yeah. Yeah. There's no. Yeah, it's not an easy problem to continually update the MLM head either. It would be maybe worth adding that this MLM head in Splay doesn't need to be like a billion parameters. Well, maybe a billion would be good, but it doesn't need to be 100 billion. But like, yeah, that's such a fascinating nugget of system design you just shared with the Twitter thing, and yeah, it's really interesting. I've seen this other company called Perplexity AI that Aravine Srinivas is. I think he's the founder CEO of it, and it's cool because he worked on Curl with Peter Abil on this contrastive representation learning for robotics, where they're doing the same kind of idea of vector optimization to learn a state space for robotic control. And so I think it's really cool that now he's working on the search space too. But it's like the other approach is like natural language to SQL, something like that, where like instead of and I'm getting a little off topic, but it's like kind of related to Twitter, and it's about like putting tweets into data stores and then parsing natural language queries into the SQL. But so that's like another idea, I guess, is
Mhm.
like you would parse the query. Yeah, I think I've already explained it, but what do you think about that idea? Like you take the query and you turn it into an SQL query in, yeah, and like that's
Yeah.
then.
Yes. I know what you mean. It's like it's very similar. I think DeepSet did that, right? So you can, or maybe it's opposite. I'm not sure. But like if you have a probably the same. If you have like a
Mhm.
table, right, with fields and rows,
Yeah.
I don't know, let's say list of mountains with their heights and so on. So you can actually have a question: what is the tallest mountain in Europe or Asia?
Mhm.
You could turn that query in natural language into SQL command and say,
Mhm.
select, you know, mountains from this mountains table, or, order by height, reverse, right?
Mhm.
Descending. And so um, I like this idea. And in fact, actually, I think, first of all, this is already doable, right? So if I understood with with the deep set doing that in Haystack. But
Mhm.
I also came across this idea mm, during my PhD research. Because so the problem there, I believe, was that it was like these engineers working on building aircrafts, and so they had to read a ton of manuals. But once you read the manual, you still need to go and look up that specific number somewhere in the database, right? So basically they do like
Mhm.
multiple hop approach, and that may take like forever. Like, you
Mhm.
first of all, you need to crunch through a ton of text material, and then somehow summarize it, and then, okay, now I need to go and look up that number in the database. But what if you could ask a natural language question to the manuals, then convert that to a SQL command, which would know to go and look up in that specific database table and give
Mhm.
you the answer. So, like, the manual doesn't have it, but it has some instructions how to find it.
Mhm.
And then you would kind of like convert that into, through this meta language, convert that into SQL, and then get that answer, right? And this was like pre dense retrieval
Mhm.
era, obviously, but I think I still feel like it has the merit to it.
Yeah.
Like,
Mhm. I would. Well, I guess two things. So I think first, there's this problem where you search like for airline manual, some specific detail, and it's like in result 7. Like it almost got it. Like it's not like not in the top 100, but it's 7. And to that problem is where I think this GPT index, like recursive summarization or create and refine summarization, I think that'll solve that problem. And yeah, well, so I then coming back to this idea of natural language to SQL and like structured, unstructured data, on the other end, you can also parse the tables into text. And so I've seen that done too. There's like wiki tables to text. And so me personally, my favorite application is scientific literature mining and searching through scientific papers. And so you could parse out the tables to turn like the results tables to turn it into natural language. And I mean, there's so many fascinating things. So it's like with a knowledge, let's say like a knowledge graph. The idea of the knowledge graph is if I have Dmitry Khan, hosts the Vector podcast, is a product manager at TomTom. With knowledge graph, I can, I compress the representation of all these facts into one structure compared to having the set of sentences, right?
mhm.
And
Yeah.
yeah, so maybe if I can kind of plug something I've done. So I have this paper that will be published pretty soon. It's about it's in the Florida Atlantic University PhD. It's an interdisciplinary team with the College of Nursing and a local healthcare system. So we have electronic health records that describe COVID-19 patients, and we're trying to predict survival outcome, treatment forecasting, prognosis, all that kind of stuff. And so the thing that we explored in this paper is let's switch from the structured tabular data to parsing it into natural language text, and let's turn it into like clinical narratives, or let's do this thing where you do if feature name equals, if feature name equals, then label, right?
Yeah.
So there's this paper from the University of Wisconsin called Language Interface Fine Tuning, where they do that same idea, but it's like the UCI machine learning repository data sets. So I think I know that I'm taking like a walk around all sorts of things, but
No, it's
like,
cool. It's cool. It's cool. I'm sure the listeners will be like, "What?" But I know, like, it's also what I heard from my listeners, for example, in the podcast, is that they actually do use these episodes as an educational material. So that's why, if we can stuff as many links to papers and your work, they can go and study that.
Yeah, cool, cool, cool. I To summarize, I guess the question is like, how are we thinking about structured and unstructured data? Because the deep learning systems, you could parse out the structure into unstructured, and then you have the transfer learning is really easy, right?
Yeah. Yes.
Or you can keep the structure, and then maybe you can learn a better representation thanks to the structure. And with that question, my interest has been really heavily in these causal DAGs and this idea of uh, creating structured causal relationships between variables. I still have no idea how you can take like Wikipedia text and turn it into a causal diagram. But I have an idea of like, if, and it comes back to this AGI versus superintelligence idea. If I have a superintelligence and it's reading search literature, I want it to have some kind of causal diagram of our current model of search stuff. So like, it has some model of how BM25 is indexed, the limitations of it, SPLADE, this representation, this MLOps problem. It has like some structured representation of all these problems, such that when the new batch of archive papers or tweets, however the news is coming into
Hmm.
it, or experiments, right? It looks at its causal diagram to say like, this violated this claim, like, because that's the thing. You see a paper like autoregressive models as search engines, or you see like what was the name of that where it's like transformers as a differentiable search index, like you see some title like that that
Hmm.
violates your causal diagram of why things are the way they are, and that's what like inspires your interest. So that's that particular angle of it is
Yeah,
yeah.
exactly. I'm also thinking, and I haven't explored this topic myself yet, but so let's say if you take a language model like BERT, which was kind of like you could say statically trained once on Wikipedia or news content, right? But the world is changing every single day, right? And
Mm-hmm.
your model doesn't. So what you could do is that you could introduce knowledge back to the model. And I'm still like on the risk of kind of exploring this. I think Niels
Mm-hmm.
Remmers talked about it recently, like how you can incorporate knowledge in the language model. So for instance, what like the way I see this before I even like read these papers, I could probably try to reinvent a wheel is that
Mm-hmm.
so the language model might figure out that the question is about the president of the United States, that specific one, let's say Obama or something. But then the question is Obama still the president of the United States? And so
Mm-hmm.
now the language model is kind of like handicapped. It says, well, I actually don't have, last I know, like ChatGPT does that, right? Like I
Mm-hmm.
was trained by 2021, so I have no idea what happened in 2022. Sorry, goodbye. But like it could say, I figured out the context. I know roughly what you're asking. This is the person. I know this person. I know that what the president means. I know the country, United States. But you're asking me a factual question. So what it could do is actually it could go and ask a knowledge graph, which is updated without recalculating the embeddings, which is solving
Mm-hmm.
the MLOps problem, right? So it's another data structure. It's a knowledge graph. It's being updated as we go, and so it goes and says, "Hey, let's." Coming back to your question on structured language, like in graph systems, you also need to form your query in a certain way. So it forms the query in a certain way and traverses the graph and then checks, is Obama the president? The answer
Mm-hmm.
is no. It goes back all the way to the maybe language model, I don't know, maybe some other layer, and basically presents the answer to the user, right?
Yeah.
So that's just one thought before I even dove into this topic of incorporating knowledge in LLMs. I would probably think like that.
Yeah, I love that you brought that knowledge graph. It's like, and that's kind of like GPT index as well as LangChain. I can't believe I haven't brought that up until now. We can talk about that more in the neural search frameworks discussion on the WeVA podcast. But like this idea of different kinds of external memory, and I don't know what's wrong with my brain today, but I keep like branching into completely. But
I
like,
don't think it's wrong. I think it's the right setting. It's just not suitable with coding or something.
yeah, yeah. But like, so I was recently talking with Shukri, who just joined Weaviate as well, about this idea of metadata re-ranking. So one approach is you have the XGBoost re-ranker, where you take in the BM25 score, the vector distance, and then also symbolic features as the input to the XGBoost re-ranker.
Hmm.
So the thinking was, okay, do we want to store this metadata in Weaviate as well, or do we go get it from Redis or a feature store, something like that, where we get that kind of property? And so it's like the knowledge graph idea connects to that, because it's like, okay, are we going to build the knowledge graph in Weaviate? Should it live in Weaviate, or should we plug Weaviate in with something like
Hmm.
Neo4j, or is it a top level controller like the neural search frameworks thing you're describing, where it's, you know, something that hooks into Weaviate and hooks into Neo4j, relational AI, Tiger Graph, I don't know all the RDF ontology
Hmm.
technologies, but you know, like it has separate, and it's a higher level that picks between the indexes. So it's, yeah, it's like what kind of technology is built in Weaviate, and that's not even really up to me. Like I just, you know.
Yeah, yeah, exactly. But I think it's kind of fun to brainstorm with you, like what, like we kind of like intuitively find these limitations together, and at the same time, these limitations may lead to future discoveries, like on engineering and research. And like when I was giving this keynote at Haystack, where by the way, Vivian guys were also present, and other guys as well. Um, um, like I didn't feel bold enough to say this, but I think I will say this now, at least, that I feel like engineering and research are kind of like indistinguishable in the amount of intelligent power you need to put into this to solve it, because it's not like given, right? Like if this data structure inverted index is designed like this, and you do have the issue of early termination because you cannot like waste so many CPU cycles, then like okay, without reading papers, can you go and solve it, like being just an engineer, so to say? No, you can't. It's like it's super hard. Like you need to start coming up with like new vector space model, which was invented when in 60s 70s, I don't know. So like can you come up with like completely new model? It's equally hard, as in research, when okay, you know that sota is now this, can I beat it somehow? But it's not like you are just beating sota for the sake of it. Maybe some people do, but like I would take the stance of not doing that. Like I would try to solve an existing problem, right? So I do want to surface, as you said, more relevant document to the top, or maybe even a passage, maybe in a number. So I keep pushing for that. So both of
Yeah.
these, to me, they're like they require so much intelligence,
Yeah.
so that they become indistinguishable in some sense. Like what exactly are you now solving? The MLOps problem? Are you solving the the inverted index data structure limitation problem? Or are you solving how do I retrain the embeddings, how to retrain the model or fine tune the model, and I don't recompute the embeddings because it's way too expensive? Someone needs to pay the bill.
Yeah.
So so does it make sense? Does it resonate with you? Like what are your thoughts on that?
Yeah, our CTO Eddie and Dillacker has written about product engineering, and like on this meta of like how do these decisions get made, and it's like I think there's a book called I've changed my office. I don't have a bookshelf behind me. I used to be in podcasts, and I'd be like, it's that
Yeah,
one.
yeah, I still have it actually. Yes, in the podcast on the screen.
But it's like ask your developer is a title, something like that, about
Uh-huh.
and well, okay, so that maybe I got a little off top, but this idea of research and engineering, I think the scientist is very like metrics oriented in a different way. Like the engineer, like the diversity of the tests and the data collection is more important when you're the scientist, sort of.
Hmm.
The yeah, the engineer needs to build like smoke tests, sort of, whereas I see the scientist needs to like have a very rigorous data collection kind of, because that's sort of how I see
Hmm.
the distinction in responsibility, sort of, if that makes
Yeah,
sense.
yeah, it does.
Yeah.
It does actually. Yeah, you gave a very good distinctive, feature. What I was trying to say is that, like in engineering, you still have a plethora of options, like combinatorial explosions in certain
Oh.
cases. There are also mundane parts in both of these, right? So, like, we are not talking about them, but like they do exist. But like, you do have these points, like, okay, should I branch this way or that way? Should I step back and rethink? And that's, yeah. But
Hmm.
I agree. You gave a really good example of, like, in research, I do care about data so much. In
Hmm.
engineering, it's probably the quality assurance department that is going to worry about, okay, what data we're going to feed into the system to try to kind of maybe break it and see the
Hmm.
limits, and where it breaks, what do we need to fix, or is it kind of like stable, waterproof enough to release,
Hmm.
things like that. So, but yeah, I agree.
Yeah, I think if I can stay on this a little more, I think this like generalization testing, like the industry of quality assurance, but for deep learning, is going to be a really fascinating. I'm like excited, like how I think when we first met, you had written this. Not all vector databases are equal, and I thought that was so insightful because it was like a you told the story of an emerging market, and that was so interesting. I really look forward to seeing like the story of the emerging market around generalization testing. I think like with the beer benchmarks, that kind of thing, where it's like you create some million scale data set and have the NDCG recall precision with all these queries. I think maybe also this idea of like A/B testing with models is going to be more popular. I was when I went to NeurIPS this year, and there was this talk from Dr. Joo Ho Kim about interaction centric AI and how that might differ from the first paradigm of model centric AI, where say you judged a image generation model purely based on like inception score for shade
Hmm.
distance
Hmm.
to feature spaces in real
Hmm.
images, and then to
Hmm.
data centric AI, which is like I think Snorkel AI is very responsible for like branding that term and making it so popular. But it's like you're really
Hmm.
focusing on the curation of data. Like your language model is like Mosaic ML's latest PubMed GPT. It's about like you have this particular data and you like clean it and you make it
Hmm.
awesome. And then I
Yeah.
think interaction centric AI is like a new way to evaluate models where it's like A B testing driven kind of, or like how quickly can you perform a task? I don't know if I've gotten too off
Yeah.
topic, but
No, I think it's exactly the topic to focus on if we are serious about, putting these things out in production. Like, you do need to have and provide an evidence to the stakeholders, that, and to yourself, that this does hold water, and we can release it, and it's not going to show something, indiscriminate to the users, that they will be completely, puzzled and stuff. Or maybe,
Mhm.
there are all these numerous examples when, like Google search, when they, I think, incorporated some distilled version of bird, when they would flip the meaning, and they would say, yeah, you
Mhm.
do take this medicine, but actually in the, prescription, it says you do not take that medicine, or vice versa, so because it's not sensitive to
Mhm.
negations and stuff. So, like, I totally agree. I'm with you on that. Like, how do we QA, quality
Mhm.
assure, the systems that we release? And I think the OpenAI's team did that brilliant trick, in a way that they said, hey, here is the chat GPT, go test it, and they got like million users in the first few days,
Mhm.
because they actually do need some extra brains to go and
Yeah.
test in different, like, scenarios, and see where it breaks, or
Mhm.
maybe it doesn't make sense anymore. So, yeah.
It's my understanding that that's how like scale AI became the kings, is that they like labeled data like Mechanical Turk. I think Surge AI is something that's emerging that I've been seeing. Yeah, it's really interesting.
Yeah,
Yeah.
exactly. um Yeah, I was wondering. You also worked on this podcast search, and you had the opinion that Whisper has
Mm.
certain bottlenecks. I wonder
Mhm.
if you want to, like, tap into that a little bit.
Yeah, so I'd love to tell the story. So it comes. The kind of story behind it is, so Boris Power at OpenAI tweeted. So they cut the prices for the OpenAI embeddings, and Boris is pointing out how cheap it would be to index a massive podcast like the Joe Rogan podcast. And so naturally, I was like, "Hey, I have a podcast about
Of
my
course.
podcast," but and yeah,
Yeah.
well, Vector podcast and we did also. But so I started to be I started doing this where you take the audio files, then you put them into Whisper. I also tried like Descript is something that I like a lot. I've been using Descript for a long time for editing uh, videos,
Mhm.
and so it's like you still because it's very the podcast transcriptions. You still want to edit them a bit. You have like and like if you
Mhm.
were, yes, how I'm pausing right now as I'm talking. No, but the transcriptions, it's not quite what you want to like index to. This idea of like how do we create a knowledge base from these podcasts, because these podcasts are so like we've covered so many topics, and it's kind of easier to do it like this than to be writing all this down. And also it's very collaborative. Like the podcast, you get more people involved. It's like a community
Yeah.
building thing. So yeah, that idea of creating knowledge bases out of podcasts, like what would you rate your interest on a scale of 1 to 10 of having a vector podcast?
I mean, I would love to join to join the to join the gig here. So because I do like I was rewatching the episode with you done a year ago, and you were
Mhm.
like exploding with knowledge, right? Like in a way, you are branching out a lot today as well, exploding with knowledge because you read all these papers, you try things, you share, like Google collabs and stuff. But like how do I tap into this knowledge? Like it's very synchronous, right? I have to like there is no way to like random jump into, hey, where did he talk
Mhm.
about that model from Microsoft? Like I don't know, unless I have the time code, I don't have a
Mhm.
way to do that, right? So yeah.
Yeah, and I that's what inspires me so much. With I want to fine tune these models so badly, just on the turn taking as the positive labeling. And yeah, I
Oh,
think
can you expand a bit more on that? What do you mean?
uh, okay. Connor says, I want to talk about the turn taking. Dmitry, can you expand on that more on what that means? Connor, okay, it's like, like this is how you do the positive pairing.
Oh, that's
It's
cool.
like
That's
sequentially like that.
Yeah,
Yeah,
yeah, yeah.
yeah.
And like if you want to have more examples of what Connor said, like you could like augment with Connor's statements, like sentences. Yeah,
Yes,
yeah,
and just I feel like the potential of it is crazy. I also think like we're gonna see it like hooked into say Spotify or these big platforms that organize podcasts, and I think it'll help you like discover like because something else. It's like I love how you do this vector search podcast, and I'm also doing a vector search podcast, and it's like who else is out there doing like maybe a recommendation podcast, or like,
hmm
like it's like this kind of discovery of other people because podcasting is very like collaborative. It is a medium, right? Like it's not like you can't do it by yourself.
No, like
Yeah.
it's almost like the thing, like stand-up comedians or anyone who's presenting. You do need the audience because
Mhm.
you simply do not generate the 3D ness of your thoughts in absence of people. Like
Mhm.
it's very hard to do, and the same thing happens here right now. Like when we exchange, like I have like a full shade of these notes and stuff, right? So I
Awesome.
wouldn't be able like what like do you know these things? Do I know some of these things? It's 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 like
Yeah.
evoking in your memory. But like coming back to Whisper, like just to get it right,
Mhm. Mhm.
you're saying it's still a bottleneck in your
Mhm.
opinion. In what way?
Okay, well, I'd hate to be like quoted as saying it's not good,
No, no,
but
no. It's your opinion,
uh,
which I value. It's not. Yeah.
so if you're creating a podcast search app, you like there still needs to be a little more parsing. I don't know if you need to find. I don't know if you need to correct one and then
hmm
fine tune. So, because I've also been playing a little bit more about ChatGPT, and as I've been learning about this kind of like sequential prompting from GPT Index and LangChain, about learning like how you can get ChatGPT to maybe clean up a podcast transcription. But there's like still a pretty pretty
Yeah.
difficult manual cleaning effort in the middle of that.
Yeah, actually, I can resonate with that. Like I've worked with one startup helping them to do speech to text, right? And
Mhm.
first of all, one issue is very similar with low resource, so to say, languages in NLP is that if you don't have a model trained on a lot of examples, or maybe they've been trained on some TV shows, and you are doing a user speech stuff, uh, you know the topics are different, the style is different, everything is different, and so it breaks.
Mhm.
And so I was also alluding to the topic of fine tuning there, but exactly what you said. The problem was the output was so noisy
Mhm.
that I had to write an what I called like an NLP layer, which would go in change things. For instance, if you say
Hmm.
25 and it actually spells it out with letters, you will collapse that to a number, but
Yeah.
sometimes it would do it in problematic places, and you're like, oh no, don't do that, don't do it here. So
Yeah.
like so it's like an aftermath thing, and you would wish that the model, having enough context and knowledge about the world, should do it right as it transcribes, rather than you do this as a aftermath.
Yeah, exactly. I'm thinking the same way. It needs like it's a text layer afterwards. Yeah.
Yeah,
Yeah, exactly.
exactly.
Yeah, super cool. And maybe like as we're wrapping up the podcast, if you let me quickly tell you about ref2vec and sort of the pivot
Yes.
into recommendation. Well, so to start off, ref2vec is about is about utilizing Weaviate's data model a little more. So Weaviate's data model is designed where you have different classes. So this class could be products. This class could be user. So like tables in SQL where you have different data objects, like the high level ideas of designing data objects, and then you have graph relations between them, like user liked product.
Hmm.
So the simplest thing is that then you can represent the user as the average vector of the products that the user liked, and then you can re-rank with that, or you could just search with that vector. That could be your search vector, or you could have some other search like restaurants in Boston, and because I live in Boston and like, or oh, sorry, I didn't mean to give away Boston in the query. Say let's start from the beginning. My query is Italian restaurants, and because it sees that Connor likes restaurant, I don't know, like some North End Italian restaurant, something like that. Like it knows that I'm in Boston, so it can personalize just using that vector to re-rank to only show me restaurants in Boston. Because if you show me a restaurant in Chicago, it's like useless to
Yeah.
me. So
Yeah.
so so that's kind of the first idea, is this kind of like average the vectors to get the centroid. But then there's this idea where, and I learned this from talking to Martin Grutendorst about his bird topic library, and I highly recommend people check that out. It's such a cool way of visualizing vector spaces. But this like HDB-scan clustering. So he was describing the difference between HDB-scan and k-means clustering for how they produce centroids. And so HDB-scan has this very cool like density clustering thing. But regardless of the clustering you use, I like HDB-scan a lot. But so let's say we get three centroids. Like I like Nike shoes, Adidas shoes, and Jordan shoes, and you have these three centroids. So you could use those three centroids as three average vectors from their respective clusters to re-rank with as well, have some kind of diversity in results. And then there's just this thinking around. So yes, that's the recommendation pivot. And then there's this idea of like top level index, and I'm stealing that kind of terminology from GPT index, because what GPT index does is to represent a long document. You have again that tree summarization where you could say this is four, obviously, right? And it's four, and you summarize these two, and then summarize one. And so you have this like top level index where you search through this layer first, then this layer. And so it's like if you're asking a question like, what was Barack Obama's legacy? And then you have the symbolic filter of the titles of the Wikipedia pages, and you have where title equals Barack Obama, like that top level search will like super simplify the search space, because now you're just looking in
Hmm.
the Barack Obama article
Hmm.
compared to all of Wikipedia. So I think ref2vec also in the use of having constructing top level indexes by having document has passage, has passage, has passage again in the Weaviate data model. It can be, it's just like, I think it's a really interesting way that we're trying to use this cross-reference graph structure to move embeddings through the graph. Another idea, and I know I'm like doing 1,000 ideas, but like, could be having like a graph convolutional network where, okay, so you have user liked product, has brand, uh, okay, let's just make it a three class graph like that. And so
Hmm.
you have this graph, and you need to send the you need to aggregate the embeddings through the graph. So now it's like, should we just average? Should we try some kind of like nonlinear graph convolutional network? And the graph convolutional network being beneficial because a graph network can handle like arbitrary number of inputs. That's sort of like, isn't like a fixed input size. Like transformers, you would like zero pad it to 512 tokens, or the convolutional network is, it's like kind of
Hmm.
flexible, but generally it's like very flexible to the number of inputs. And So I
Yeah.
hope that was an okay tour of Ref2Vec, and I know I got a little
No,
distracted.
it's amazing actually, and I hope we can maybe discuss in some subsequent episodes as well, because the topic of personalization is also very interesting. And like for someone who says, okay, we just have these fixed vectors computed from the content, how the hell we can actually bring the
Hmm.
user
Hmm.
and this is what you've described. This is what I perceived from it. I think this is an excellent topic, and this kind of opens up opportunities for vector search to appeal to the search engine builders, or maybe some other engines like recommendation and so on.
Hmm.
But I think we have a ton of material. I really love talking to you. Maybe before we close off, is there something you wanted to announce to the audience of Vector Podcast?
Yeah, I think so. We have toured a lot of things, but I really hope that you'll check out the Weaviate beer benchmarks repository. So this is a recent effort around hybrid search. Coming back to that, it's been a long conversation. I feel like that was forever ago, but like the hybrid search thing has been tested with the beer benchmarks, and so there's like scales. There's like small scale beer, medium scale, larger scale. So right now there's the larger scale and some medium scale. I mean smaller scale and some medium scale. And right now we're working on the backups. But this is all based on, so Weaviate 1.15 had backups where you can back up the Weaviate instance to have like a file that lets you just restore the Weaviate instance, so you don't need to import the data. It's like it's like with the face indexes, how you can just
Hmm.
read
Hmm.
index.
Yeah.
So now what you can do is you can just load the Weaviate index. And so why this is so exciting to me is I've always been really interested in like Hugging Face data sets or papers with codes, papers with data, like this organization of data. And I used to think with like Weaviate's Wikipedia demo that it would need to be like live, always hosted. Like you click try it now, and then it's like boom, you're in the console and you can query it. But I think with this repo where you just download the Docker file for Weaviate, it's like two lines of code where you do Docker compose up and then
Hmm.
Python restore the name of the data set you want. And I think that's just as easy as having some always hosted demo. So yeah, I hope, and I think the other thing is with hybrid search, another thing that excites me so much is it's like if it's vector search only, it's like you could argue, well, why don't I just use the face index then? But I think
Hmm.
because it's got the BM25 and the vector search is starting to offer more value with like how it can help you with your information retrieval research. Uh, yeah, and in general, that's just something that is very important to me is trying to figure out how to connect with the information retrieval research. I think the beer benchmarks presents a really exciting way to do it. I do have some ideas on how users would be interested in it because I think uh, the idea of beer benchmarks is maybe you look at it and you say, okay, NF Corpus or Trek COVID or Natural Questions is like very similar to what the app that I'm building. But I think with ChatGPT, you could probably loop through your documents and generate queries gold, like those would be the gold documents for those queries. And you can do the same kind of evaluation testing where, as you mentioned, you want to see how that approximate nearest neighbor error cascades into the representation error and see what that means for your particular problem. So I hope people check it
Yeah.
out. I hope find it interesting. Cool.
Yeah, that's a ton, super packed. Thanks so much. What I like in this discussion compared to the last one a year ago is that you continue to explode with knowledge, and I hope you will continue doing that. Thanks so much for your time today, Connor, and yeah, looking forward to talk more.
Yeah, yeah. Thank you so much, Dmitry. I feel like the Vector podcast is like the Super Bowl of search podcasts, and I'm so
Oh my God,
grateful to get to
I'm
be on
honored. Thank you
it.
so much. Thank you so
Thank you.
much, Connor. Yeah, enjoy your day.
Awesome.
Bye bye.